Water. It's a substance that is essential for life, yet 1/6 of the global population lacks access to clean drinking water. We are facing a global water crisis. In fact, providing access to clean drinking water has even been identified as one of the 14 grand challenges our planet is facing. When on vacation in India, I witnessed the sight of children drinking dirty water from a stagnant pool. I instantly knew I had to do something about the global water crisis. Drinking water contamination can come from harmful pathogens, organic chemicals, and heavy metals. Now, current treatment methods include chlorination, filtration, and UVC radiation. A green and sustainable method, known as SODIS, has also been tried. However, this alone is very slow. So I hypothesized that the solar disinfection process could be accelerated by deploying a novel photocatalytic composite that incorporates titanium dioxide and zinc oxide nanoparticles. Now currently, TiO2 is coated on the inside of PET bottles, which blocks UV radiation and diminishes photocatalysis. The second drawback of current treatment methods is that TiO2 coatings wash off after several uses. My solution to the first problem was to deploy a photocatalytic rod inside the bottle, which will be in contact with water and UV radiation. Now my next step was to find a binding agent. I tried several different products and concluded that cement would be the best binding agent. So I created my photocatalytic composite with cement and sand and added water, which resulted in a reaction known as hydration. I tested it and it worked. However, it was too heavy. Then I came across a product known as 3M glass bubbles. 3M glass bubbles are UV transparent, lightweight, and cost-effective. I tried it and it was amazing. So to find the correct ratio of my composite, I conducted several preliminary experiments with methylene blue, a common photodegradation indicator, and bacteria. I concluded that the best ratio for my composite would be 1 gram of ZNO for every 4 grams of TiO2, 25 grams of 3M glass bubbles, and 100 grams of cement. So when UV radiation strikes my composite, electrons and holes are created. These electrons and holes combine with oxygen and water to create superoxides and hydroxyl radicals. Now these reactive species can oxidize organics into water and carbon dioxide. So how does this kill bacteria? Well, when UV radiation strikes, a pyrimidine dimer forms around the thymine and cytosine bases in the DNA of harmful pathogens. This prevents the DNA from replicating and eventually destroys the pathogen. So I built several different prototypes with my composite, such as a rod to be placed inside water bottles, photocatalytic spheres, and a water tank for long-term storage. I also built a photocatalytic water purification panel. As you can see, this panel is constructed out of 4 PETG tubes, each with about 30 photocatalytic spheres, and a parabolic trough reflector made of 3M solar reflector film. Now this panel can be used as a batch process. I conducted, to find if my prototypes could degrade organics and remove bacteria, I conducted experiments on methylene blue and on samples of water taken from the Nashville wastewater treatment facility. To count my bacteria, I used 3M's Petri films. The results of my experiment show that my novel photocatalytic composite reduced the amount of total coliform from more than 8,000 down to 50 in less than 8 hours, and reduced the amount of E. coli from more than 1,000 down to 0 in just 2 hours. I was also able to degrade 300 milliliters of 25 ppm methylene blue in just 1 hour. I concluded that my novel photocatalytic composite reduced the amount of total coliform and E. coli colonies below EPA limits, oxidized methylene blue faster than current SODIS methods, prevented the regrowth of bacteria, and did not wash out. Just imagine the possibilities of my composite. It can even be used to clean up disastrous oil spills. Without safe drinking water, life as we know today will cease to exist. Since the 5 minutes of my presentation, 15 children have died from the lack of clean drinking water. I will soon be contacting USAID foundations and NGOs to deploy my invention, and I hope that you too will join me in my journey to save billions of lives. Again, thank you to Discovery Education and my mentor for allowing me to combine my knowledge in physics, chemistry, biology, and math to bring my inventions to life. Also, thank you to the judges and all the esteemed scientists that were here today, and the audience for your time. Thank you.